What's up, guys? Back at it with tutoring with Mr. Sorrels, and today we're on part 2 of our semester exam review. And right now, without further ado, I'm gonna get right into viruses and bacteria. I know it's been a minute since we went over it for all of my Bearcats looking, but a quick review over bacteria, viruses, how they affect our body, how they abuse our body, and how they use our body. Let's get into some background about both. I'll start off with bacteria. Bacteria is a prokaryote. What did we say about prokaryotes that you guys need to remember for the semester exam coming up? Let's do the chant. Pro equals no. No what? No nucleus. So, bacteria do not have genetic information. That'll be useful later. Pro equals no. If they're a prokaryote, they have no nucleus, they have no DNA, they have no RNA. Remember that. 90% of bacteria is actually good. It's actually helpful. Things like yogurt are helpful bacteria. If you don't believe me, look it up. Bacteria are transferred through a process called binary fission. I have the steps and the process up there behind me. I'll get into that in just a moment. All right? Let's go to viruses now. A little background on viruses. Viruses are not cells. Viruses are not cells. So what does that mean? Viruses are the only thing that are not living. Not the only thing. One of the only things that are not living that need a host, you, to survive. So without you, there is no virus. Without the virus, without you, without your body, without the host, the virus cannot live because it is non-living. Remember that. What is the goal of a virus, you might ask? Well, a virus wants to spread and make copies of itself. How does it do that? 1, it lands. 2, it pins. 3, it penetrates. And 4, it injects its virus in you. And they usually do that in one or two ways. Do you guys remember the 2 ways? If you don't, it's okay. You're here with Mr. Sorrels, I'll remind you. So remember we talked a little bit earlier this year about the lytic cycle. That ring a bell? Yeah, that was the fast cycle of how viruses move. Do you guys maybe remember the steps? All right, I'll refresh you. Lytic viruses are the ones like a common cold where symptoms appear fairly quick, where one day you wake up, you're fine, you go to sleep, the next day you wake up and you're sick, you're infected. How do those happen though? Well, lytic has a little bit of different steps about it. 1, the virus lands. 2, it chooses between lytic or lysogenic. Am I going to be fast or am I going to be a little slow? Then it injects itself into you. It begins to synthesize and assemble more copies of itself. It begins to make more copies of themselves inside your body, and then last, it releases its virus and its new copies of itself on all of your DNA, your body, and your cells. So, let's talk about lysogenic for just a second. Lysogenic is the slower processes of the 2. Lysogenic, a lot of the same steps, but slower timing to get there. They like to attach, inject. Here's where they slow down. They like to integrate with your cells. Instead of synthesizing and making more copies of themselves, they like to get to know your cells. They integrate, they watch, they study, they look at your cells, and then they begin to make copies. After the copies are made, then they disconnect. What do they disconnect from? They disconnect themselves from the actual virus. Huh? Y'all will learn about that more. But let's get into binary fission before we get out of here today, all right? Binary fission, a lot of the ways that bacteria spread themselves. We start off with a parent cell, okay? Parent cell has a fine DNA, wakes up, all right, I'm ready to go, I'm good. Little does the parent cell know it's infected with bacteria. So what does that bacteria begin to do? It begins to replicate. It begins to make copies of themselves. All three of these have common themes. So if you could just know slow, fast bacteria, that's how I remembered it, you'll be fine. So DNA begins to replicate. DNA loves making copies of itself, especially when it's not supposed to be there. So it makes more copies of itself. And once it's done synthesizing and replicating and making copies, what are those copies ready to do? They are ready to split. So now we have daughter cells that are made. Daughter cells are now carrying the old and the new DNA, the infected and the uninfected, the virus and the non-virus part. So, binary fusion, lytic, lysogenic, viruses, bacteria, no. You guys know this stuff and you guys are going to do great on your final, but that is it for part 2 of our final review.